regression this morning. First of all, I'm going to give you a brief introduction to regression before we solve one or two problems. Regression simply means the relationship between two variables, that is an independent variable and a dependent variable. That's the brief definition of a regression. And regression is of different types though. We have the linear regression, the multiple regression, the orthogonal regression, and the orthogonal polynomial regression, and also we have what we call the split regression. But all these are advanced types of regression. But today we'll be looking at the simple or the linear regression. And when you talk about regression, there is always a general formula for a linear regression, which is always given as y equals a plus bx. Of course, this is the general formula for every linear regression equation. Although sometimes you will see plus EI. Yes, there's a reason why they normally add the plus EI to it, but for the secondary school level, they will not really need it. So anyway, but it's part of the formula. So this y is what we refer to as the dependent variable. The dependent variable. And of course, your x is what we refer to the independent variable. And of course, your a is what we refer to as your intercept. Your intercept. Not just your intercept, your y intercept. And of course, your b is referred to as what we call the gradient, or you can call it slope of the regression equation. And of course, your e is what we refer to as the error term. The error term. Very, very important. Or you can call it the stochastic term or the probabilistic term. And it's very, very important to include it to every regression equation. But right now, we want to learn how to formulate a regression equation. We want to learn how to formulate a regression equation. So, to formulate a regression equation is very easy. We have various methods in which you can actually formulate a regression equation. We have the ordinary least square method, we have the graphical method, we have the matrix method. But today we'll be looking at the ordinary least square method. So let's look at the ordinary least square method. Now, the ordinary least square method is like a formula method. You can also call it a formula method because it involves the use of formula to, formulate the regression equation. So to use the ordinary least square method, these are the procedures. Now, given y equals a plus bx, your b is always equals to n summation xy minus summation x summation y all over n summation x squared minus open bracket summation x all in squared. Now, if you observe this regression equation, now in a regression equation, what you are majorly looking for is the values of the a and the b, because once you are able to get the value of a and b, then from there you'll be able to formulate the regression equation. And the formula for obtaining the value of b is given as x. And of course, your a is equal to, I think, summation y minus b summation x all over n. That's the formula for obtaining the value of a when it comes to the ordinary least square method. It means that, or it implies that, without the value of b, you cannot obtain a. Of course, you can see that from here. You see that in the formula for obtaining a, there is b there. It means you first of all obtain the value of b before you obtain a. Let us take a very simple sample. Sample. For instance, assuming they say, find a regression equation. Find a regression equation of y on x from the below table. Let's say you have something like this. Let's say you have your x and your y here. And of course, let's say you have 2, for instance. You have 3. Let's say 7, 1, and let's say 8, 2. So which times? Let's say here you have 3, 4, 4. Let's say 3, 1, 7, for instance. Now they are asking us to find the what now? A regression equation of y on x from what now? The table below. Now all you need to do is this. Now, solution to this. The first thing you do is to see what you can do to obtain those parameters in the formula. What are the parameters? The value of n, the value of summation xy, the value of summation x, the value of summation y, the value of summation x squared, and the value of summation x. And to do that, the best way to do that is to create a table. You know, in statistics, generally, table enables us to, analyze data easily. So we are going to use table to obtain all this. Okay? All right. Now, wow. Please, there is a major instrument that we actually need whenever you are dealing with statistics, which is your calculator. Please, when you are dealing with statistics, you always deal with your calculator. Now, what I'm saying is this. So from the table, we already have our x this way, and of course, our y is here. And from the formula, we need xy, and of course, we need x here as well. So what we do is this. Your x is already there, which is 2, 3, you can see it from here, and 7, I think we have 1, 8, and of course 2. And of course we have our y as well, which is 3, 4, 4, and we have 3, 1, and 7. So you obtain the value of this. And what's the meaning of xy? It simply means the product of x and y. That is, you multiply x and y together. So that means this is x, this is y. So it means you are going to say 2 times 3, you have 6, and of course 3 times 4 is 12. I think you have 28. You can confirm them with your calculator. And when you multiply this, you have 3, and of course this gives us 8. This times this, that is 14. Wow. All right. Then from here you move to the column of x squared. X squared simply means you square your x values. That is, you multiply them by their sets. That is, for example, now this is 2. 2 squared simply means 2 times 2. Of course, that gives us 4. 3 squared, you have 9. 7 squared, I think 49. 1 squared, 1. And then you have 64. And I think this gives us 4. According to the formula, the next thing you do from here is to, sum everything up. You get the summation of x, you get the summation of y, summation of this, and of course, summation of this. Summation simply means you add all these together, and of course, when you do this, I think you should be having 10, of course 10, you have this 13 plus 10, I think that's 23. So you have 23 here for the summation of this. And when you do these two, I think this is 8 plus 4, I think that's 12. 12 plus 10, that's 22. So you have 22 here as well. And then when you sum this together, let's see, I think 14 plus 6, that's 20. And of course, these two together is 40. So 40 plus 20, I think you're going to have 60 plus 11, that's 71. So you have 71 here. And let's do this together. You have this plus this, you have 50. Right? Yeah. And this is 68. When you do this together, and of course, 68 plus, let's say, 59, and then 59 plus 4, that's about 63. So 63 plus 68, you have 1, 12, 13, of course. So you have 131 here. Wow. So we have been able to get the solution of all these columns. The next thing is to what? Now to introduce the formula and then substitute to get your value. So I told you before now that, of course, for you to get a regression equation, you need two values, which are the A and the B. And I said you can only calculate the A when you know the B. So you first of all go for B. And I said the formula for obtaining B for a regression equation is n summation xy minus summation x summation y all over n summation x squared minus open bracket summation x all in squared. So you have this. So with this, you can obtain the value of B. So let's see. Wow. All you need to do from here is you just substitute. Okay, you substitute and it's not difficult. So your B from here now becomes your N, of course. Sorry, I didn't explain the meaning of N. N, rather. N simply means the number of observations you have there. That is 1, 2, 3, 4, 5, 6. You can see that we have 6 observations. That means our N is equals to 6. So you should know that your N is 6. So you have 6, of course, multiplied by, this is summation xy, and of course, this is your xy, summation xy is 71. So you substitute the 71 here, minus, of course, this is summation x. Summation x is 23 times your summation y, which is of course 22. So you have your 23 multiplied by 22 all over your n, which is 6 times your summation x squared. Of course, summation x squared is 131. So you have it this way, 131 minus summation x all in square, that is 23 all in square. So we have your B, From here you have your B now. Quickly, let's look at the calculator value of all this so that we'll be accurate and correct. So we have 6 multiplied by 71. That should be, I think, 4 to 6. Yes, you have 426 minus, of course, 23 times 22. You can also point your calculator if you are watching. So you have 506 here for conformity. And then divided by your 6 multiplied by, I think, 131, which will give you 786 minus, of course, 23 squared. You're going to have 529. And then from here you have B to be equals to, of course, 426 minus 506. That should give us negative 80. Then divided by your 786 minus your 529. That gives us 257. Then the B now is giving us 80 cost divided by your 257. That is minus 0.3113. Cost to 2dp now, we have negative 0.31. Wow, wonderful. So from here, you can now go ahead to obtain your A, because I told you that your A is equals to summation y minus b summation x all over n. Of course, with this formula, you have your A to be equals to summation y is this, which is 22. So you have 22 minus cos your B. Remember that your B is this. Please, when you are substituting, always try as much as possible to substitute this value, not this, in order for you to what? To obtain the accurate result. So you have open bracket negative 0.3113 close bracket, multiply by, of course, summation x, which is 23. So you have your 23 here. Then everything divided by your n, which we agreed, or which we counted here, which is the number of observation, to be 6. And then from here, now, you see that your A equals to, of course, 22. Then you can see that minus times minus collapse to plus. And then from here, you multiply your 0.3113 times I think we have 23 there. So we have 7.1599. Then everything divided by, I think, 6. Then from here now, A, when you do it very well, let's do it direct. So you have 22 plus your 7.1599 equals to, divided by 6. I think we should be having 4.859. Let's just say 998. And then from here you have A equals to 4.86 to 2 dp. So from here now, let's say from the general regression equation, now, which is y equals to, I think, a plus bx, it means that y is equals to, of course, our a is now 4.86 plus your b, and our b is minus 0.31, then you have your x. So you can now see that y is equals to 4.86 plus times minus, you have minus 0.31 x. Wow! And this becomes your regression equation. Please note, this regression equation can be used for so many things. You can use it for prediction, or you can use it to forecast, and you can also use it to know the trend of so many things happening around the economy. Thank you for watching this video.